Hello, it's been a while. I'm back. So, first things first, for anyone who's here just for the title, it's a work in progress. It's not done yet. And with that out of the way, on to the rest of what I had planned. So, first things first, before I get into all of this code, I was first going to talk about a few changes to the way that I'm planning to produce content. For one, as you may have noticed, it's been, I think, like 2 months since I last uploaded anything, and that is because I've had a lot of work that I've had to do, and it is likely going to stay that way for a while. And so, rather than what I was doing before, where I was doing almost weekly uploads of stuff, I'm now going to be just doing, I'm going to be working on stuff when I have time. Along with that, the next thing that I was going to talk about was that on a lot of these, what I've been doing is I've been going through and I've essentially put in YouTube chapters for every single one of these sections. So every method class, every method, etc., etc., etc. In order to reduce time in making this, and also I don't know how many people are using them, but I'm going to stop making them so detailed in that respect. And then thirdly, what I've been doing so far is I've basically been going through as I've been recording or as I've been writing this code and going through it line by line. Again, in order to make sure that I actually can program and I don't have to do these in like 4-hour sessions. I'm going to stop doing that, and I'm going to do sort of more progress-based check-ins whenever I have time. So, yeah, that should also hopefully mean that these are shorter and less rambly, which I think has been one of the reasons why view time is fairly short on these videos. So with that out of the way, as you might have seen from the title, the plan for this is I recently transitioned, recently being a while ago now, transitioned over from using my Minecraft Forge client, which has all kinds of cool custom mods that I've made up that I've written up in it, over to Lunar, because frankly speaking, it's in a few ways superior. But annoyingly, this means that I don't get all of my cool, awesome mods. And so, I was thinking that, especially because the stuff I've written isn't that complex, I'm working on a way that I can get those mods to load inside of Lunar Client, or rather outside. I'm going to explain that in a second, and with a second being now. So, essentially, let me go over the basic design concept. So, Lunar Client, of course, is proprietary software. Is proprietary the right word? It's not open source, which means that we can't recompile it with custom mod loading stuff built into it, and it obviously doesn't have the ability to just load some jars that I've decided to create. And so, essentially, we can treat it as a black box, which is just a Minecraft client. So this we cannot edit. It's just existent. And personally, I don't play survival as much as I used to, and most of these mods were actually designed to work on servers. So over here we're gonna have some Minecraft server. And what normally happens is the client will connect to the server, and because we can't edit the code in the client, we can't change that, and because we can't edit the code in the server, we can't change that either. And so we're kind of stuck. However, what we can do is what out in the world would be called a man-in-the-middle attack, and essentially put our own custom client server here, and no one's really the wiser. So what this means is that we essentially start up a Minecraft server and tell the client to connect to that server, and it does so because, we control what the client connects to. It will connect to whatever server we tell it to, and then the server and then that server starts up its own Minecraft client, in air quotes, which connects to the actual Minecraft server. And again, Minecraft is not necessarily open source, but it's been disassembled and such, so or it's been we have ways of knowing what the protocols are for that, so we can essentially build our own Minecraft client that connects to the server. And so with that, the client thinks that it's talking to a server, and the server thinks it's talking to a client, but really they're both just talking to our little code here, which means that we have control over all the packet streams. And considering that all my stuff does is basically mess with how chat's formatted and add commands and such, that's perfectly fine with me. But of course, you could also probably do some other things by messing with entity data and item data and such. And so, with that in mind, you can then ask the question, well, why can't we do this in the real world? Because, I can have over here my web browser, let's say Google Chrome, and we can also down here have google.com. And, why can't we just essentially do what we have here and just stick our own little bit of code there and have it mess with all the packets again, and then you're sending fake data. Well, as I said, this is what's in the world known as a man-in-the-middle attack, where we have our man in the middle who's intercepting the connection and can read everything. Now, the difference between Minecraft, which allows us to do this with Minecraft and not with an actual web browser, is that essentially the Minecraft, in the real world, this is prevented, or on browsers, this is prevented by technologies like by encryption technologies. So essentially, and I will, while I'm doing fewer YouTube chapters, I will do one that just skips over this section, so look in the description. But I will have, sorry, other noises. But essentially, Google has there are a bunch of companies in the world which have essentially little tokens assigned to them, which only they can have, which essentially are trusted by everyone. And they go and they use their tokens to sign off and say, yes, Google.com has this, you call it a signature, almost. I don't think that's the right word, but I'm going to roll with it. And then if you go and you use that signature on whatever piece of data you're sending, then only Google can read it. See, in the world, it's called public and private keys. So this is RSA. So essentially, we have some other authority which is trusted by everyone, and due to math and such, you can't forge their signature on anything. And they go and say, this is how you create data which can only be received by Google. And Google will go and send over, this is how you securely send data to me. You can check that and say that, yeah, that was signed by our overlord companies. And then you will be able to securely transmit data. And so while you can put this client or server in here, it won't actually be able to read anything due to math, basically. However, if you've ever gone and started up your own Minecraft server, it's basically you download the file, you run it, and then that's it. So you haven't gone through and you haven't talked to our company overlords and had them sign off and say, yes, trust this person. And so Minecraft doesn't assume that you'll be trusted. And so, yes, it does do encryption, which does stop anyone from just snooping on the connection, but it doesn't check that you are an actual verified server. And actually, from the client's perspective, it isn't connecting to this server here, it's connecting to this server here. And so, what Minecraft does have, though, is it has its own Mojang servers. We're going to get this out of the way. So, it has Mojang servers, and essentially what will happen is when it's connecting, the client will go and it will use signed math numbers to essentially say, Mojang, I'm connecting to this server. And then when they connect, the server will say, hey, Mojang, did these people connect? And Mojang will go and respond, yes, they did. However, if our server just connects, then the server will go and say, hey, Mojang, did these people connect? What? No, they connected to whatever this weird server is. And so what that means we have to do is we essentially have to send the same packet from the server to authenticate it, but that's really the only bit of actual security in there, and the rest is just stuff we can manipulate. And the great part about that is because we're then using Minecraft's protocols, this will actually work with basically any Minecraft client that's out there, assuming that you're running it on the right version and such. So now that I've gone ahead and talked about a bunch of theory, let's get into the actual code. Again, I'm going to try to move somewhat faster on this than I would normally, but essentially here's what we got. So the key that allows all this stuff to work is because, if you remember, we have to send some signed math numbers and such over to Mojang to say that we're connecting to this server, but we don't have those numbers. And so what we can do is the game will have those numbers. And so, shoot, do I have my... Here we go. And so, if I can drag stuff, what we'll have is I wrote up this file here, which essentially registers this as an actual installation of Minecraft. So if we go in here and start the launcher, then we can select this like any other version, and then the launcher will actually just feed us all of these authentication tokens and all the player data because it thinks it's just another instance of Minecraft. And again, this also isn't using some glitch because, like if you've installed Forge or Optifine, they will go and create their own profiles in the launcher. And so we're doing the same thing. And because the game's the one connecting, it gives us all the information on how to go and connect to a server. And so essentially what this is doing here is it just goes and parses out the access token, which is the actual stuff we have to send to Mojang, the directory of the game, as well as the player's username and UUID, because that can all be useful. It will go and package it into some arguments object, which, essentially, how do I do this? It's that. Oops. Shoot, 1 second. I know this is a command. Shoot. I'm sorry. I've done this like a million times, but I don't remember what the command is. It's not that. There we go. Got it. So essentially, we create the object, and then we just call this set method, which essentially stores it so that we can access it from a static context. Nothing much there. And then if you see me do some other mods, I don't know if I actually posted these, but come on, open the file. There we go. But essentially, this is just some code that I've copy-pasted over a bunch of projects, and it essentially handles all the files and stuff to make sure that any variables we throw in here, sorry, not in here, up at the top, I haven't added any yet, but any variables we put in there can be stored and loaded between versions. And so we're going to just quickly initialize that and load in anything from an already existent file. Then we're just going to generate an RSA key pair, which essentially is Minecraft uses encryption. We don't have access to the server's encryption tokens, so we can't just pretend to use the server's tokens. But we'll create our own and pretend we're a server and a client, and basically it works. So we will go and we'll generate ourselves a key pair that we can use. And again, this is the part where I essentially written test code that will be changed later. But essentially, we start up a server on port 25565, which is the default Minecraft port. And you can see I've been testing this on Hypixel and also on a local server. And then we will wait for a client to connect, and then open a connection to the Minecraft server. And then we just call this connection handler.start method, which is going to go through and it essentially creates two instances of this connection handler class, one that connects the client to the server and one that connects the server to the client. It links them to each other and then starts both of them in threads, which essentially they have a run function. Before I get too far into that, if any errors occur, I essentially use these create and wait for functions. In fact, why is this not in a create and wait for? 1 second. Text area frame, IO. Oh, that's why. All right. So essentially, save, create, and wait for. All right. One thing at a time. This should be changed. This bit here to utils.safe. There. sorry. So essentially what utils there are a bunch of utils methods here. I'm not going to go over all of them. The code's on GitHub as always. As I said, I'm trying to move faster through these videos. But essentially, we have Fox methods, which converts byte arrays to byte arrays because Java doesn't like it when you do that. Create and wait for is for like GUI frames. So essentially, it will create a GUI and then wait for the user to close it, so that we can just wait for that because it'll happen over different threads and such. And it also auto syncs it with the AWT event thread. We have stuff here to convert there's a bunch of stuff here having to do with like reading bytes and such, like read hex stuff, and where is it down here? This is all like just dealing with all kinds of different bytes and like writing different bytes and stuff to streams and whatnot. And then also down here, you can see here is the link to the documentation I've been using to actually build this. It just talks about all the Minecraft packets and whatnot. And Minecraft, what it sends some of its values as is like is stuff called var ints and var longs, which are ints and longs which have a variable length. And so this is code I copied off the website and edited a bit that just goes and parses those out of streams. And so also we're in Java 8, so we don't have a read end bytes method on streams, so I wrote one. And then what we also have, stuff that reads and writes strings to those arrays and byte arrays. So Minecraft packets have to be encoded a specific way with all the different data types, and so these are just convenience methods for doing all the different writing types of those. This is writing a long, essentially it just casts it to a byte, or write byte with a long. It's used somewhere, I'm sure. This is the actual stuff that is somewhat important. There are these methods which are just called safe, which essentially says this function can safely fail without breaking anything. So if something wrong happens, then just say whatever, it's done for, I guess. But continue executing of code and don't report an error or anything. Just something happened, ignore it. Safe, create, and wait for just wraps create and wait for in a safe call. And then there's also these methods called no fail, which says this statement that we're passing into it shouldn't fail. It should run, but if an error occurs, then something has gone horribly wrong. And so check your installation, make sure that your system's compatible, because that shouldn't happen. Now, after I've gone off on that tangent, we are going to go back to connection handler, which essentially we store a bunch of values we get and we save those. We have a start a new thread function, which just starts this because we're a runnable, and I'll get to the run method later, in a new thread. We have some set compression and stuff and enable encryption, which I'll get to as we use it. Block packet, again, I'll get to that. We have a safe write function, which essentially what it does is because you can imagine each of these, there's two of these running at once, and they're each sending data in different directions, and they're both responsible, and for each of those, they're both responsible for writing their own data and writing other data that's not necessarily initiated from them to that socket. And so these write calls, they aren't atomic, and they sometimes take place over a couple of different lines. And so safe write is just a wrapper for something which makes sure that a lock is set so that we don't end up trying to write two things at the same time and writing a bunch of nonsense data. All right, now here's the run method. Essentially, this is a standard run loop. If any errors occur, then report them to the user, and I'll talk about how this line works in a moment. And finally, make sure that we close the sockets. Before I go on, safe, create, and wait for, if you remember, means this method can fail safely. Create and wait for, create a frame and wait for it to finish, or create a frame and wait for the user to close it. And text area frame is just a class which essentially takes in a message and displays it to the user inside of a text area, or it will use an exception and stuff, but it will display the error to the user as an error. All right. We'll also log it to the system error stream because yes, so that debug. Then we're gonna have our running variable. So while we are running this loop, try to execute this code which says if state is status, because if you've seen that all the title information and icons and stuff, that's server status, and at least at the moment I'm not writing this to deal with those status packets. And so if it's status, then this is some code which essentially says read in whatever data we have and pass it through because we don't care about it. And then otherwise, if we're not doing status, then we're going to do our main read loop, which is actually going to execute our custom code. And if an error occurs, then check if the sockets are closed. If so, then set running to false so that we exit the loop. And if some unknown error occurred, then throw it down to here so that we can deal with it as an unknown error. All right. Next up, this is the main read loop, and it does all of our custom injection code. So first things first, we're gonna read in as a var int, we're gonna read in the length of the packet, and mark just sets essentially a marker in the stream, which means that we can jump back to that marker because these are buffered streams. So this means that we can essentially read the same data multiple times without having to cache it ourselves anywhere. Next we have this block packet command, and that's what that block packet method up there did. It just what's the word? If it's set to true, then that means don't send the packet that we have or that's coming in here. Don't forward it along because we've done something else with it. Then runnable command. There's probably a better way to do this, but essentially there are some cases where we have to actually do our final send of a packet before we execute some last bit of code. And so this is just for, if I jump down to the bottom of this method, this is just so that after we do that send, we can then run the command afterwards without having to, send it up here and have the same send code in multiple places. It's just difficult because also streams are marked and it's easier to do it in a way like this. And most of the time it's just none, and so it's fine. And do nothing is just nothing. So there you go. Next, we're going to create a byte array called packet data, and this is, I believe, just the data that we will, this is just the data of the packet that we're reading. And the reason for this is that there's multiple ways a packet can be read, and so this makes sure that whatever happens, the data will eventually end up in this variable. So then if compression threshold is -1, which means compression is disabled, then packet data is then read in the length of the packet and store that in packet data because that's the data. Then reset it to our marker so that we can read the packet again and set that marker again. Whoops. Then we will read in the packet ID as a var int. And if it's 03 or 046, because I pulled these off of that documentation, which again I'll link in the description, then that means that we're receiving a compression packet. And so set the compression threshold to read var int, and compression threshold essentially means what's the word? It means the max number of bytes that can be put in a packet before we start compressing stuff. So we're gonna save that, and then we're going to tell our other connection handler that, hey, we're now doing compression, and set compression is pretty simple. It just stores it in the class. So it just stores compression threshold up here. So we're going to set the compression on our other listener, and then this is where command comes in handy, because we don't want to set the compression until after we've forwarded this set compression packet along to, I believe, the client. So that way, because otherwise we'd be compressing the how do I do compression packet, and that just doesn't work. So we'll store that in there. And actually, well, whatever, it's fine. And then if packet ID is 0, this means that it's essentially a what type of connection is this packet. So we're going to just switch on what our current state is, because that will tell us what to do. And essentially we only care if this is a handshake packet, because otherwise I believe it's either nonsense or stuff we don't care about. And so if it's a handshake packet, then we're going to block the packet so that we don't forward it on. And there's a reason for that. Next, what we're going to do is we're going to read in all the data from the packet. So it has a version, which I believe is the protocol version, a name, which is the name of the server, I think, the server port. So, shoot, I don't remember what all these are. But essentially, there's a name and there's a server port. I don't remember what exactly they do, but I guess I could look it up, but it's not really important. And then next state is the one of these states that we're moving to next. So the handshake state means we're still setting up the connection, and that's what we're in now. Whoops. And if you notice, like the status state, that's the one where we just forward data. And so based on what that state is, we are going to set our next state. And again, if it's 2, we'll set it to play, and otherwise we're going to set it to status. Next, we're going to get our byte array output stream, and this is essentially the way that I've been writing data by queuing it all in a byte array output stream and then writing that stream to the other stream with safe write methods and such. So first we're going to write our packet ID back, and that's 0x00. Then we're going to write the version. Then we're going to write the version, and we don't need to change that. Here's the difference though, server IP. So if you notice, the rest of this stuff is essentially just cloning the packet, but we're writing our own server IP. And so the reason for this is like if you try to connect to Hypixel, but you're connecting to this server, so you'll see that the way you do this is you tell your Minecraft client to connect to the server localhost, and that will connect you to this processor. But that means that when it's talking to the server, it'll say, "Hey, I've connected to you. Oh, but I've connected to you by connecting to localhost." And if you try to send that to some servers, mainly Hypixel, which I tested this on, it will go ahead and say, whoa, how are you connecting from localhost? That shouldn't be possible. Don't come here. And so what we do is we tell it, no, we're connecting to whatever IP the user has specified us to connect to, which for now is just localhost, or I put MC Hypixel.net in here because localhost doesn't actually care. But we'll write that and say we're actually connecting to this endpoint so that we can still connect. And then safe write just goes ahead and writes all this stuff to byte arrays and whatnot. Whoa. Safe write does. And also a thing to note with safe write, so you can see that this is writing the byte array. But what it does is it will actually first write the length of the data to the stream. And the reason for this is that, the first thing we read in was the packet length, and so that's the first thing we're going to write. So back down to this. Next up, if packet ID is 0x01, I believe this is encryption. So this means that we're receiving a packet that's talking about encryption, which means that, we're going to want to definitely read it. And so we block it if it's going to either the client or the server. So if it's going to the client, then we're going to parse out this stuff, and essentially, without going through what all this code does, essentially it says, so wait until, what's the word? This should also be read. But essentially, what am I trying to say? Yeah, so essentially we use that key that we created earlier up here as our key for the server. And so we replace out the key that the server is sending with our own custom key. And we send that. And we send that along to the client. And then what we have here essentially is saying wait until the client goes and acknowledges this, because otherwise we will be like enabling encryption on our side, and the server will still be using non-encryption, or rather we will attempt to read data before. So sheesh, I don't know how to say this. Essentially, the way that this works, and I'll go over this in a moment, is we go and we say we have some stream, and we will call a read method on it, whatever, I don't need this. We have our stream, input stream, and we are going to call a read method on it. However, when we enable encryption, what it does is it will actually change that stream. It will essentially delete that stream and set it to a new stream. But if we do that right after this is done, before the client has gone and enabled encryption, which does that stream change, then it will be reading from the old stream and it won't have all the decryption stuff on it. And so this just says wait until encryption is enabled before we do any more reads or before we try to read anything. All right. And also, I believe it also does this setup encryption here, which again doesn't do much. It just saves a server ID, which is something used for sending what's its face, Minecraft. It's something used to identify servers by Mojang, and it doesn't really matter. It's just like, it doesn't have to be a specific thing. It just has to exist. And then we also save the server's public key so that we can encrypt data when we send it to the server. And we do that on both sides because on the one hand, we have to read data from the server, which decrypts with the public key, and on the other hand, we have to write data to the server, which takes the public key. And so both sides get a copy of that information because they both need it. Next, if the client's sending a response to the server, we will do a bunch of stuff which essentially has to do with parsing out what the client's key is, because it's going to be sending a key back to the server of how to securely communicate with it. And because we sent it how to securely communicate with the server, we have to go and decrypt that because it's sending it encrypted so no one can snoop on the connection. And we store that key and so that we can use it to communicate with the client. And then because this is a non-symmetric key, which means that we use the same key for reading and writing, we can actually just pass that key along to the server because we have it, so we can now decrypt the entire connection. And again, normally this key would be sent securely, so we couldn't do this, but because we're acting as the server, we can. All right? I know that I'm talking somewhat fast and not explaining this. Feel free to leave a comment if you need me to explain any of this further, or maybe look it up. I don't know, both work. In any case, this essentially just does all that decryption. And then what we have is we have this function here, which does join server as, and then this name, which I'm not going to attempt to pronounce. But essentially what it does is this code. And I'm not going to go through what all of it does because, again, you know, this can be read on the documentation that I'm going to throw in the description. But essentially, it sends a packet to it sends this magic packet to Mojang servers, which says, "Hey, I'm joining a server," and so it's going to send that over to the Mojang session servers. It does all this stuff to like create a packet and sign data and stuff, and then we call this utils.post method, which posts data to a server, and it just does this. Again, not going to go over exactly what all this does. It's mostly code that I like half copied out of Forge, or technically Minecraft decompiled code. You know, not exactly the same, but the same basic ideas. And so join server, joining the server, and then this name is the name of the service Mojang uses. So in any case, if that fails, throw an error. And then we're going to call this enable encryption, which up here you saw we called setup encryption. This just stores some of the encryption information we have here. And then what we do here is we enable encryption, which is actually taking that encryption which is actually what turns on the encryption. And before I go over that, I'm now thinking that I should probably explain something. So what happens in the Minecraft flow is that the Minecraft server goes and talks to the client, or the client, sorry, I should say connects to the server. And in the handshake process, the server will go and send back to the client, "Here's how you communicate with me securely." However, that encryption algorithm that they've used, where only the server can then read the response, takes a long time in computational standards. In reality, it's fast by human standards, but it takes a long time computationally to do the calculations for that. And so the Minecraft client is then going to generate a key which can be used for a faster method of encryption, but everyone can read it if they have the key, and send that back to the server securely. And then the client and server both switch into encryption. So what we're doing is we're going to connect to the server. In the handshake, the server sends us back how to securely communicate with it. We then send back to the client how do you securely communicate with me. The client goes and sends its everyone can read it key to us. We can forward the same key to the server, but now all three of us have that key, and so we can snoop on the entire connection. All right, I hope that made some more sense. So what we're doing here, we do enable encryption, which essentially says, and keep in mind we're enabling encryption on the other one, so we aren't, I'll get to that in a moment, but essentially we store the key that we're using, we initialize some ciphers and such to mess with data, and then we update our streams, which were previously just buffered streams, and we first do cipher streams on them so that we can decrypt and encrypt the data automatically, and then we wrap them in buffered streams again so that all of these mark methods still work. All right, good. So next, after we do all that, we're going to essentially re-encrypt this entire packet and such using the server's public information rather than ours, and then we send that to the server. And then, once we've done that, we're going to say, wait. We're going to say, ooh, what's this? Yeah, no, we're good, sorry. So we're going to wait for this packet to go and be sent, even though technically it should be sent here, but again, wait for the method to run its completion so that we don't end up messing up some info, which we would. And then once we've gone through and finished this method, enable encryption so that everything we read from now on will be encrypted, and then call this other.notifyAll, which just says, as we did up here, hey, I've enabled encryption, you're safe to use encrypted data now. All right, that was long. I swear it gets somewhat easier. So next up, we have essentially the compression. So this code here deals with compressed packets. And again, first it reads in the uncompressed length, and then it does some stuff to decompress it. I'm not going to go through how all that works again on the website, but essentially, if the length says I'm not going to go into how it works, and I immediately go into how it works. If the length is 0, then that means that compression is disabled, so just read the packet. Otherwise, go through and decompress the packet. All right. Then finally, if key is not null, which means that if encryption's been enabled and we aren't about to run some command, which means that we've already messed with some important packets, then go and notify packet handler, which is not fully implemented yet. Come on, there we go. As you can see, not really implemented yet, but notify packet handler, which is the code that's going to actually be sending the packets out to all the mods that are installed, that we have a packet for it to mess with. Then reset the input stream back to our marker and read in the packet. And if we haven't chosen to block it, then write the packet back out to the other end and then run the command. All right. So finally, what we have here is essentially a bunch of write methods, which can be used by anyone to write data to this side of the connection. Or technically, they're set up to work to either side. So if you have either connection handler going either way, it'll work. Because if the direction is wrong, then just feed it to the other one. And that's thrown at the beginning of all these methods so that it's nice and it works. So what we'll do next, byte array, we essentially just, if we were given a byte array, then call, what in the world was this meant to do? I'm sure there was a reason for me to write this. Oh yeah, so essentially if we were given there are many ways for someone to actually write data, and one of the ways that I like doing, because all of the write var int and write string functions require a stream to write to. So if you call this method, then you set up this IO consumer, which is essentially a function which takes in a stream. And what that means is that we'll say, All right, we'll create a stream. We'll give you the stream so you can write whatever data you want to it. And then we'll just call our own write function with whatever data you wrote to the stream. So next, again, first things first, if the direction is wrong, send it the other way. And then what we'll do is we'll first write the, this one takes in a packet ID for it to write. This one takes in a packet ID and the data. Basically, write the data, combine the ID and the packet data, and call it to the third write method, which actually goes and it writes the compression if it has to, this is the code that does the compression stuff. And this also deals with like writing all the packet lengths and stuff by calling safewrite. And because all this does feed through safewrite at the end, that also means it does all the locking and stuff that it has to. All right? With that, that's all of connection handler, which I can assure you is probably one of the longest files, if not the longest. It's in the top 3 for sure. So next up, I'm going to quickly go over what list frame and text area frame do because they are not that difficult. So I already went over text area frame. It just shows it some text to the user. List frame is basically the same. These are, at the moment, just used for error messages. It essentially does the same thing, but it takes in a list of column names and data, and it displays the data to the user as a list or as a table. I don't know why it's called list frame. Don't ask me. I named it. I don't know why. Next up, we've got, all right, actually quite a bit of code, but next up we have, this is what's eventually going to become the mod loading code. It's not currently connected to anything. We're going to have entry point, and again, because this is a work in progress I will quite possibly change a lot of this stuff. But we'll have an entry point which will act as the entry point for the mod, and it will, exist as entry point. It essentially will call this create function to create it. We have this @interface mod, which mods will have to have. It defines an ID, name, description, version, and also any dependencies. I'll get into dependency format later. Next up we have here, actually before we go over that, let's go over semantic versioning. So I don't know if you know what semantic versioning is, but essentially it consists of 3 numbers. There's number dot number dot number. So like 1.0.0, 2.5.3, all that. And what it means is that this first number is the major version. Anytime that you do something which breaks old code, you increment that number. This is the minor version number. Anytime you do something which adds new functionality but doesn't break existing code, you increment that one. And this is the, what's it called? It's the third number. That's it. Major number, minor number, the third number. I think that's probably right. And what it does is anytime you do something which doesn't add a feature but like fixes a bug or something, then we increment that number. And so essentially it's a group of 3 numbers, and so these are some utility classes for dealing with it. So essentially validate just checks that this is a valid semantic version. Like it contains 3 numbers like that. That's all it does. Then we can create the semantic version with either an array list of, I really did create this weirdly. So the way that I program semantic versioning is actually so that it can be a list of any number of numbers separated with dots. It doesn't have to be that way, but this code supports it. So if you can either send in an array of ints and we'll just copy that in. And notice that if you actually read all this, semantic versions are immutable, which means that once you create one, you can't change its data without having to create another one. Okay, so then, or you can create it from a string, which will validate the string and make sure that it's a valid version. If not, we throw an error. And actually, I don't know if you can see the problem with this code, but I certainly can. And essentially, you saw the way that was written, if it did validate it as correct, it would set the version and then still throw an error. So now it won't do that, which is good. So then if this happens, then read it as a stream, split it on periods, convert it to integers, and convert it to arrays. So essentially, that's that. Actually, wait a minute. This is weird. Oh. So technically, there is this weird case where this could happen if you use like millions of version numbers. That could break it, but I'm going to go on the idea that no one's going to enter a version number that's millions of versions long. Or like, I'm talking billions, like 2 to the 31 minus 1. If you enter a number over that big, then I don't know what you're trying to do besides break this code. In any case, and also this isn't important enough or critical enough that we need to care, basically. Then we have a compare to function so that we can compare one to another, and it just checks, if this is greater or less than, and so if this version is less than the version we supplied, we'll return -1. If it's greater than it, then we return 1. Otherwise, we return 0. And there you go. So with that, and the way it does that is it just iterates down the line of numbers. So checks the first one if they're equal, the second one if they're equal, third if they're equal, etc., etc., etc. And there's the list. So finally, oh yeah, and if they're all equal, then return the longer one as the greater version. So essentially that's what that does. Then we have the semantic version range, which, how do I do this? Every time. It's also a bunch of code. Essentially, it has a lower bound semantic version, an upper bound semantic version, and whether they're exclusive. And so what this means is that it also has a validate method. It can also be parsed from strings. I'm not going to go over all the logic for that, but essentially, what you can have is you can have essentially how many ways of writing this? There's a lot. I'm only going to go over a few. Says a few, proceeds to write 50 billion of them. So essentially, these are more or less all the ones you can have. You can see how you can mix and match them. So if you write this, that just means, well, first things first, this is the basic semantic version. You have a lower bound and an upper bound, and you say if it's less than or if it's greater than or equal to the lower bound and less than or equal to the upper bound, then it's valid. If there's a parenthesis on it, then that means that, and I'm not going to write LBUB on all of these, but you can kind of get what I'm trying to do. Then this means that it can include the lower bound, so greater than or equal to the lower bound, but less than the upper bound, it can't be equal. Or you can just have something like this, which says greater than or equal to the lower bound and no upper bound, and similar for like upper bound and all that stuff. And you can mix and match to see how you fit. And again, this just means match everything. And so it does that. And then there's also a contains method, which checks that if this version is in the range using all that stuff. And I'm not going to go over all the logic for it. Again, all on GitHub. And then next up, we have, this is the mod loader. And here you can see all the different ways that you can do it because I tested them. But essentially, this is what will actually be loading the mods into the game via the mod files. So first things first, we are going to call this is basically the main method, which is load mods. I think it's fairly straightforward in the name. Put a lot of time and effort into it, obviously. So essentially, we're going to iterate over all the files in this gamedir.list files, and this should probably be changed. Yeah, this should be changed. I'm just going to. I should really do it now. 1 second. Shoot, how do I do this? Shoot, paths.get. Oh, wait. So it was at this point that I realized that this is the way you're supposed to do it. Gameargs.get gamedir.toPath.resolve. Resolves the other path against this path. In the simplest case, the given path does not return. Yeah. So resolve CSMods. And does this return an error in the case that dot file? Sorry about that. Let me just make sure that this doesn't throw an error because it totally could. Hello, show me my 1 second. No, I don't want to look at this. I want documentation. I know I said I wouldn't code, but now I look at this. I am. So not doing it, then factory return null. Okay. So Actually, does that throw an error? Guess what we're doing? We are going to test it. This is how I code. So we're just going to say for string s new string array test. Do like that. As you can see, this should just print hello world once, which it does. So the question is, does this happen if I do null? Null is not compatible. Yay. So guess what we get to do? This returns a file array files equals this. Files equals files is null question mark files no question mark new file array that colon null. Whew. All right, sorry about that change. So let me just go over what I just did. So now, rather than looking in the game directory, we'll look in this CSMods folder. In there, list all jar files. There you go. And then if for some reason that returns null, then just use an empty array because there's no files. All right, that's it. So next, for every file that we read, if it's a directory, then ignore it because we don't care about directories. Otherwise, we're going to call load jar, which does essentially some stuff which says access the jar, create a class loader for it, and then grab all the class files in the jar, turn them into classes, and throw them out so that we can use them. So for each one in there, if it has an @mod annotation, then store it, then map it as this is the mod, this is the class file, store it in this mod's map. And then if for some reason some error occurred, then figure out what file path caused the error, and then display it to the user and say, null, we couldn't load the files. All right, good. So next. So this is essentially a bunch of stuff which does error checking. So first things first, all mods have to implement entry point. If they don't, do an error, and then display info about the mods that don't satisfy the requirement of implementing entry point. Same thing with invalid mods. This calls this validate mod function, which checks that the @mod annotation has valid data. First things first, all mod IDs have to match this string, which says you can include letters, numbers, underscore, and hyphens. All other mod IDs are illegal. Next, make sure the version is a valid semantic version. And then for all the dependencies, make sure the dependency matches one of these, essentially. And then if it doesn't, return false, and then we'll say, wait, it's an error, something's going to go wrong, oh no. Finally, or well, almost finally, there's a few more things to go. We say, make sure that all the mod IDs are distinct, so we can't have two mods with the same ID, because that gets confusing pretty quickly. Next up, we will load all of these entry points as entry points, yes. And then loaded mods, array list. So hopefully I've done this. There was actually a bunch of code I did because I implemented another mod loading system later. And essentially what this does is it's checking to make sure that all mods have their dependencies satisfied before we load them in. However, I'm not sure if all of these are being loaded into the same class space, if you know what I mean, or into the same class loader. They aren't, but I'm not sure if they'll be able to access definitions from each other, which could cause problems depending on how stuff, which could cause problems because they're dependencies. But I guess we'll figure that out when we test it. So essentially, we'll store all mods as being unloaded mods, and then for while we still have mods which are unloaded, then attempt to find all mods which have all their dependencies met. So that does this, and it goes through and it checks all the dependencies, and it says, all right, are all the dependencies met, and are all the dependency IDs within range? So, or do we have all dependencies, and are they the right versions? Then if so, then store it as a loaded mod, and then add it as an entry point, So mods.getMod, if you remember, that will go and get the class that goes along with this. And actually, that's a little concerning because this is... Oh wait, no, we're good. So we're going to get that class and create a new instance of it, which should be an entry point because they all implement entry point, and store that in entry points. And if an error occurs, tell the user about it because it's not supposed to happen. Then add that mod to the list of mods which we've loaded so that we can use it as a dependency, and remove it from the list of mods which are unloaded. So what am I trying to say? Remove it from the list of mods which haven't been loaded yet. Yeah. And then keep doing this while we've loaded some number of mods. So the number of mods that we've loaded this round, because you can see we always reset it, is not 0, so we did something. Actually, yeah. So we did something. Or if we empty out all the list of unloaded mods, we're done. Finally, if there's some number of mods that are unloaded, that means dependencies are missing. So go and yell at the user to say install your dependencies because we can't load stuff otherwise. All right, good. Whew. So that's another long file done. This is one of the other long files in here. All right, and I believe with that, that's all the mod package. So we got one more, and this is essentially going to be packets, which I'm worried because I haven't looked at it today. I reviewed the rest of this code before going over it because I wrote this like a while ago now. So, okay, this is long and I don't know what it does. I should know because I wrote it. What is all this stuff? Here, packet parser. This seems important. So, yeah, essentially what this does is so when all the packets come in, they're just a bunch of bytes, and this doesn't do it yet, convert them into packet objects so that we can easily use them. So first we have these things called packet specs, which are specifications for packets, and you can see here they are. They have a function to actually create the packet object. You can see t extends packet. And then they have this types and get type method. So get type just returns the class of the packet because I guess we need that somewhere. And types just calls what's its face? Types just refers to all of the different types of data that need to be sent out in it for it to work. All right. So next up we have custom serialization, which just means does this packet type have to be custom serialized, which means that it does its own reading and writing. Next we have a read method, which just calls packet parser read, and a write method, which just calls does nothing because we're not doing custom serialization by default. And then it's time to figure out what all of this packet parser stuff does. What's this as well? Oh yeah, this is like this is the entire class definition. Wow. And this does all of this stuff. Brilliant. As I said, I did not review this bit of the code before talking about it. So adding a specification just says put the class type of the specification and map it to the spec. Same thing, we have these object parsers, which, if I remember correctly, they're what converts so if the packet says I need a string stored, it will take in the string and convert it into those types. Oh, I should probably also explain this connection. I know I'm jumping around a lot. This is how I read code when I haven't done it in a while, or when I haven't looked at it in a while. So this says get type, or this says types, which is all the types of data that have to be sent in. This is get values, which are retrieving all those types which correspond to this specific packet. All right, I'll go back to this now. Whew. So next up, what we have is read. So this will read a packet in. First things first, it's going to take in what class of packet to read. If we don't have it, then say that we don't know the specification. Otherwise, read from the specification and the stream. First things first, if the specifications if this specification has not already been registered, then go and add it. Otherwise, once we've done that, go and continue. if we are using if this specification says that it uses custom reading and writing, then have the specification go and read in the packet for us, because it can, apparently. Then read in the types of values we need. Object types length. So then create a value array where we're going to store all these values. And then for each one, we're going to get the type for that in types. And then if we don't have an object parser for it, then say we don't know how to read this type. Otherwise, go and read that value in from the stream with the given object parser. All right. Next, for writing packets, you can just given a packet and a stream, to which we'll say, here's the packet, the class in the stream, to which we'll say, if we don't have the specification, unknown specification, otherwise convert this stuff to a specification. And then, what in the world was I doing here? Get type, code object values. Oh, guess what? We've just found another error. Yay. So first of all, this will just convert to a specification. This has to do packet. So what we were doing here is I copied and pasted this code and I didn't do it right. And this encodes objects into the stream. Yeah. Okay. So, eventually I'll set this up probably so that it uses like types which are stored in context and stuff to essentially not have to pass in an output stream, but you can just give it a packet object and it will do the rest for you. But for now, this is how it is. Also, this code isn't actually hooked up to anything, so, dot get values. So what we'll do is, first of all, if there's custom serialization, then what in the world? G packet. If we use custom serialization, then the specification can do the writing for us. Otherwise, read the types in, read the values for each type. If we don't have a way to parse the value, then help unknown type. Otherwise, retrieve the object parser for the type and encode the object into the output stream. All right, good. Next up, packets. So the way that you're actually meant to write a packet is you're supposed to just return values from get values, but like for var ints and such, I know I'm jumping around a lot, but I promise this will be useful. But for like var ints and stuff, that has to have special encoding for it, but really at the end of the day, in the object, we want it to be stored as an int. So the way that I'm having this done is that we'll return an int through the object array and we'll pass in an int. But when we throw it in the types array, we'll have these var int and var long dot class. It's a class array, right? Where is packet spec? Yeah. So we'll pass in. So we'll do. So we can do var int dot class and var long dot class in the types, and those are these wrapper types. And as you saw, wrapper type is basically this. It's just wrapper type itself is just a type so that we can identify stuff. And it's packet. And as you can see, they don't actually do anything, and they're static and final, and yeah. So basically, there you go. And then abstract object array get values. That means this will be the method which will grab the values out of it that we would need to reconstruct it or to send the packet and such. At this point, my brain's going a little insane from staring at code that I don't know what it does, and I haven't talked about how in the world to make this all work, so I'm jumping around a lot. I'm sorry. But I hope you can distill some sense from this. So essentially, this is an object parser. It has 3 methods on it. Well, 4. It has decode, which will take an input stream and decode it to the type of the object parser. Encode, which takes a object and converts it to a stream. And get type, which just returns the type that this object parser converts. What is this used in? It's used in something. But essentially, what we then have is we also have this encode object, which just calls encode, but it casts it object type T because we can't pass T's around outside of this class and such, and so this way we can call methods and such. Basically, we need it. So then we also have all these nice methods which create object parsers for us. So we have mapping, which takes parser, enc mapper, def mapper, and essentially what it does is it says this is the underlying parser. This is the underlying parser. However, we're actually going to need. We have a parser of type T and we want a parser of type U. Here's how you convert between T and U, and here's the type of U. And so then it goes through and it says, all right, here's how you decode using that data. Here's how you encode using that data. There you go. Object parser.of. This is the basic function. Here's how you encode an object to a byte array. Here's how you read an object from an input stream, and here's the type. And then these are the methods that implement that. There's another of function, except this one has a length on it. And this is for ones where where rather than having a input stream here, because we're outputting to this, but rather than having an input stream here, we want just a byte array because it's easier to deal with bytes, and this is for like numbers and such, when it really is easier just to deal with bytes. And so for that, we take in the length as well, and then we just auto-read just that number of bytes that we need. Next, we also have another of function. This uses streams on both its inputs and outputs. And so, again, same basic logic for how to implement that. And then finally, we have wrapping. And this is where wrapper type comes into play. And it essentially says we have this, like for varint, we have this type varint, but it's really just an integer. And so this says we'll return a parser of type T, but with class type U. And so basically it says the type of the parser is this wrapper type, but the underlying parser and what this parser really is this parser here. All right, that's about it. And then finally, this should be the last file that I'm going over. It's been long. I've been at this for like an hour according to the timer. But this is going to be the defaults. This is going to be essentially what registers all of the parsers is essentially all of the default object parsers. So yes, you can add your own because you can if you want to, but by default, this supports all the strings and integers and such. So register defaults, So register defaults just says we have this parser here, which is defaults, which returns an array of all the basic object parsers. And so just for each of those, add it to the parser list. And then here we have of number. And these are just like utility functions for creating object parsers because a lot of them are very similar. So this is saying create an object parser to parse this specific number type. And so length, the number of bytes in the number, the byte buffer function that we use to encode it, and the byte buffer function we use to decode it, because all this stuff is used by just putting the bytes in a buffer and then reading the bytes out of the buffer as a different type. And byte buffer from Java's Neo package has methods that do all this nicely, and then what's the type of it. And then here we have this get bytes function, which says, let's see, what does this do? This will, I believe, this just reads out, this converts a byte buffer into all of the bytes that are in it by using some utils get bytes methods and such. And this is the length of the bytes. And then from bytes, what in the world does this do? This returns a function which converts. So this converts byte arrays into a function using a buffer. This creates a function that converts byte arrays into something with a function that uses converts byte buffers into something. And again, that essentially just says, I believe, convert the bytes into a byte buffer, and then convert the bytes into a byte buffer and then return them. All right, and now I can quickly go over all the different types of parsers. So int parser and long parser are pulled out because we have these wrapping calls to var int and var long. So essentially, int parser. Ooh, what's this? Ooh, nice. I made these so that you can just access the dot classes. That's nice. All right. So in any case, so this means like if you're in the packet and you're writing the types method, you could write returns integer.class, comma, just var int rather than var int.class. It's the little things that make programming code nice. In any case, so to parse an int of number for, actually, wait a minute. Ooh. It was at this point that I realized that this code was wrong by quite a bit. Let's think about this. Yeah, this is wrong. I'm going to fix it after this video. Probably not now because it's getting late and I have other things to do. And this will not be something I can do in 2 seconds. I don't think. What would I have to change? So we'd have to do that. Oh. Okay. So essentially what I have to do is I have to change this stuff. You know what? Let's do it. So first things first, this is an int parser. This is a long parser. I no longer need them up here because we aren't just wrapping them because I have no idea why I did that. Because I was like, oh, a var int, that's just an int, right? Yeah, no. Wrapping new object parser dot of. Which one do I want to use? Darn. Do I have the stream one? This one does streams, right? Let's see here. Utils write var int. Utils read var int. Integer dot class. Okay, it's not throwing an error, so I'm going to assume it's good. Utils dot write var long. Utils dot read var long. And long dot class. All right. I was wondering if it was going to throw errors because these have like primitive types in them. Because you see int there and int there, but I guess it's good, and I'm not going to question it. So now that that's been fixed, here's what we got. So to do a Boolean, essentially, we have some functions which say if it's, what in the world? Why is that? Oh yeah, so this is the one that just does byte arrays. They're a byte long. Essentially, write the byte 0x01 if it's true or 0x00 if it's false. And those are the functions that do that. If you're just writing a byte, then guess what? One byte's in a byte array, and there's all the data that does byte writing for you. Again, just copy the byte around a bunch. Then a short has 2 bytes, and here are all the stuff in byte buffer that does short. Same with ints, longs, floats, doubles. They're all more or less the same. And then for string, we're going to do parser.of. Here's how you write it. Here's how you read it. These are just functions in utils, and we're doing string. And then these are the ones that you saw you can just write. They are wrapping. So for var int, we are going to be wrapping an integer buffer, which reads and writes var ints. And for var long, we're going to be wrapping a long type, which does read and write var long. All right. And then finally, we have one for UUID because that's used a lot in Java. Oh wait, there's one more down here for byte array. But first, we have one for UUID, and the UUID class has these most and least significant bits, which are just byte buffers, basically. And so here's how you write it, and here's how you read it according to Minecraft stuff. There's 16 bits in it, or bytes. Actually, 64 bits, yeah. So 16 bytes. Is that right? 64 bits, 8. Yeah, that's right. So then finally we have byte arrays, and this just does essentially utils read and write bytes, and it does some boxing and such, but you know, nothing much. And yeah, wow, that was long, and yeah, but I don't remember if I plan to test this. I'm not going to test it because, let's be honest, I haven't actually booted this up in a while and I don't remember fully how it works. But first things first, this is why I like to go and look over code in depth, especially when talking about it. You catch all these like little errors in it that otherwise you'd have to figure out during debugging. So, you know, bug fixes, boop, and we can just commit all of that. Come on, you can commit. I believe in you. There you go. And we'll push that. So again, I'm going to put the documentation I'm using for this and the GitHub repo and stuff down in the description. And I mean, that's really all I've got for today. So stay tuned. When I have time, I'll try to continue working on this because it would be great for me to be able to use all my cool mods in Lunar Client, best of both worlds. And yeah, so that is all I've got. So thanks for watching, and bye!